Here we're going to be using Gauss's law to solve this type of problem where we have two conducting spheres. So we have one conducting sphere at the center, which is in yellow. It has a radius A and it has charge Q1. And then we have a spherical shell that's around it that is charged negative Q2. It has an inner radius of B, outer radius of C. The first part of the question asks us to find the electric field at the region R is less than A. So by R, we just mean any distance R away from the center. So here, for instance, what's the electric field right there? Now, hopefully you remember, the electric field inside a conductor, it's 0. So don't use any equations, don't do anything. Just say E is equal to 0 and move on with your life. So B is going to be figuring out what the electric field is in the region of A to B. By that, I mean this region here. So what is the electric field at any point inside this space? Now, there's no conductor inside here, so it's not going to be equal to 0. The first thing we're going to do is figure out how much charge is enclosed by this region. So by that, I mean if this is A, and we have our conductor inside here. And then I want to figure out what's the electric field here at this point R. First thing I do is I draw a circle that has radius of R that's centered around my conductor like this. And I need to figure out, well, what is Q enclosed? So how much charge is inside of this circle or sphere that I drew that has radius A? And we see here that it is Q1. Because this has charge Q1, there's no charge around here. So that's that. Now I'm going to use Gauss's law, which is here. So I know that the integral of E dot dA is equal to Qin over epsilon naught. And this is the surface integral. Luckily for me here though, I know that my electric field is pointing radially outwards, like so. I also know that my dA here is also pointing radially outwards as such. That means that the angle between these two is 0 degrees. Cosine of 0 degrees is equal to 1. So when I do this, I have surface integral of E dA cosine of 0, which I can then write as E times dA. Now I also know that my electric field is going to be constant at every point R. So here it's going to have a certain value pointing in this direction radially outwards, but here it's also going to have the same magnitude pointing also radially outwards. Because E is a constant, I can take it outside of my integral, and then I get this. And this is equal to Qin over epsilon naught. Now this here, this is just asking me to figure out what the surface area is. I know what the surface area of a sphere is, and that is 4 pi r squared. So my final answer here is going to look like this, is equal to Qin divided by epsilon naught, or E is equal to Qin over 4 pi r squared epsilon naught, and that is my answer for B. Remember, this is valid when R is between, like I said, A and B. Okay, so part C is going to ask us to figure out what is E when, instead of being between these 2 points, we're between B and C. So when R is bigger than B and smaller than C. This is going to be in the region here. And this is our conducting spherical shell. And we know that inside a conductor, the electric field is equal to 0. We don't need to do anything more than that. We know the electric field is 0. Now for D, they're asking us, what is the electric field in the region R is greater than C? We need to figure out how much charge is enclosed inside that region. So here, remember, we have our conductor, we have our conducting spherical shell, right? So this has charge Q1, negative Q2, And I want to know what's the electric field way down here. First thing I do is I draw a circle that has radius r. So this has some radius r, and I need to figure out what is the amount of charge enclosed in this volume. So Qn is going to be equal to, well, I have Q1 and then I have negative Q2. So then that's Qn, and the same thing as before, I'm going to have E times 4 pi r squared is equal to Qn over epsilon naught. And then I'm going to have E is equal to Qn, which is Q1 minus Q2 over 4 pi r squared epsilon naught. And that is my answer when r is larger than c, so when I am outside of the system.